Hello guys, and in this project, I built a smart parking lot system using an Arduino that detects cars on the entrance gate and tracks how many cars are parked in real time. So the goal was to create a miniature parking management system using sensors and embedded programming, and whilst this has been done by other people already, I thought it would be a great opportunity to challenge myself and apply my experience and knowledge with embedded systems from scratch. I didn't follow any steps or copy from anybody, as I did mine my way, but you can design it to your own liking if you want. I'm in a little bit of a time crunch, so today's video is going to be a short one, but without any further ado, let's get into it. So starting with the hardware I used an Arduino Mega 2560, and this provides plenty of I/O pins for multiple sensors and modules, though you can use other microcontrollers such as the Arduino Uno or even an ESP32 if you want to go advanced. And each parking slot comes with its own infrared sensor, the obstacle avoidance model, that detects if a vehicle is parked or not. And as for the entrance, I used an ultrasonic sensor to measure how far a car is, and if it's nearby, the servo will then raise the gate automatically in real time. And of course, we can't forget about the 16:2 LCD display that shows how many cars are parked. And designing this was actually pretty fun. I used a few poster boards that you can get in Dollarama, and I decided to go with a 7-slot parking system and made cutouts for the entrance and exit. And after attaching all the sensors and modules to the board, wiring was both easy and complicated. It was a matter of breadboarding where I attached components to a ground source, a 5-volt source, and various pins on my Arduino. It wasn't hard, but just look at the wires here. It's a mess, I know. I plan on making a PCB for this project in the future, but this is just what I have currently. After hooking everything up together, I did lots of coding and debugging using the Arduino IDE, and you can judge the way I do my code if you want to, but it just works for now, and I'll clean it up eventually. The GitHub repo is in the description below. So at the top of my code, I included the libraries for each component and defined their own respective pins. And to avoid blocking, I also used global variables, which is useful for timing. Then, at the setup function, I start serial communication, set the 7 IR sensors and ultrasonic sensors as input, and initialize other components such as the servo motor and LCD display. I didn't want my code to be too long, so I created the park toggle function to compare the current IR sensor value with its previous value, and this helps with counting how many spots are occupied, which get updated whether a car comes or leaves, and this gets sent out to the LCD. And lastly, in the main loop, I made 2 else if blocks, one that detects whether a car is near the gate within 10 meters, and one for controlling servo if a car is nearby. And again, check out my GitHub repo if you want to see the code. It's a very basic project, but I'm very pleased with the result. However, I did come across a few problems here and there, and one of them is actually with time blocking. When I used the delay statement, it actually blocked other processes from running while the servo would do its own thing. Let me show you. Alright, so this is with the old version of my code, and this is with the delay function, as you can see right there. So what I'm gonna do is show you guys what happens when I use that. So for example, like a car is parked, right? It updates automatically, as you can see right there. And the same thing with the other slot and the other slots as well. But if I park a car and then a car enters and let's say the car leaves, it doesn't update automatically. And the same thing happens if a car enters. This happens, so watch. See the delay right there? Not good. So what I did was that I replaced the delay statement with the millisecond based timing, which allowed the servo to do its thing while other processes continue to run. As for the hardware problems, I also had a problem with the infrared sensors where it would give out false positives when it's sunny, meaning that ambient light, which produce infrared light, actually interfere with the sensor. So I was able to remedy this by calibrating the potentiometer on the IR sensors, and it's not perfect, but it definitely helps a lot here. As for my future plans, I plan on designing a PCB so we won't have to rely on those wires any longer, because it is a spaghetti right now, as you can see right there. And inspired by my group project where we did passive patrol, I plan on also using an ESP32 and going full IoT, and even using a Raspberry Pi for object detection. Anyways, that does it for this video. What are your thoughts on this project? Let me know in the comment section below, and don't forget to leave a like and subscribe to my channel for more content just like this. And until next time, I'll see you in the next video.